So welcome back to the second part of practical lecture 0.1, a short introduction to Python and Jupyter. And I think in the meantime now you really know a little bit more about Python, you know a little bit more about Jupyter notebooks, Jupyter lab environments. And of course, when we use this now in the second part, which is really having more demonstrations, which are partly relatively simple, and then with a growing complexity really towards more data mining and data pre-processing, which is used in practice. Of course, again, here everything is a little bit around big data and cloud computing, but of course think away that in simulations, in physics, everywhere Python is more and more used. And also the Jupyter notebook can be, of course, used with other codes which are used in the simulation sciences on large HPC resources, things which are numerical methods, known physical laws that they have in different physics to be computed. So it's not really just a tool for machine learning and deep learning and big data and clouds and so forth. So this is really something which gets broader used. Now, the second part is really, again, demonstrations to get a little bit more comfortable around this. Also think about that, of course, we would have here now 3 lectures or 3 course hours, if you will. I usually will only perform 2, which means our Q&A session will be in the third one, usually being very short and directly after the second lecture. But this should be not only free time, right? I mean, whenever you spend the time, it's up to you. But note that the time that we have in the third course hour today would be maybe useful for getting yourself a bit more into Python if you have not seen it before. Look out the references that I have in the Canvas environment. Think about some of these resources. Also, if you think about Jupyter, you can download the Anaconda distribution. It's free. And maybe it is quite a nice time to do so. It's optional, of course, because some people really are very familiar already with Python and there's no added value in doing this or have used Jupyter for 100 times or 100,000 times. But if you have time, and of course you should use this time that we don't fill just with presentations, with something useful of really getting better to the topic. Good, but let us come back to what we learned basically in the first part. We said, okay, there are 2 types here now that I introduced. The one was really this local Jupyter, which was part of Anaconda, which you can already use directly after the course if you download it. And you see that everything here would be in the browser. And you have a kind of folder hierarchy you can go through. And when we now go to some of the simple examples that are just here prepared out of fun, there's not much with substance, but you have seen it's quite interesting to use. Make sure it is really running. There could be several errors sometimes on your computer or remotely in Jupyter. And there are several features I just want to go through. There are a couple of elements you see here, basically lots of things which are more or less self-explained, right? From edit, copy, paste, delete cells, split cells, merge cells. Cells essentially means something like this, so that you have this cell, and if you put Shift Enter, then you execute the cell. And now you can merge cells, you can actually copy paste cells to somewhere else, and of course change it, of saying 4x4 is maybe something different, and you have the same code again and will execute. When I do this copy and paste, be careful when you have more elaborate code. Here, we don't use any packages, but it could be that the import statements, if you, do imports or some variables will be, mixed up in this. And of course, here languages, you see that it's basically used here and we override it here. But basically, if you have, languages here defined, and basically you restart maybe the kernel, right? Restart and clear output. You can do this, for instance, to restart kind of a notebook, remove all output, and it's completely blank in each of the cells, so it was never executed. So, and of course, this will be not doing any harm here, but let's say we would say we remove this line, then you can directly immediately see, okay, there's the problem. We don't know the languages. On the other hand, you would say, okay, I have executed this, which indicates this number 3 here. And now the language is defined as this: German, Spanish, Icelandic, Italian. And we basically now have this again here in 4 defined. Although it's upstairs, so to speak, right? It's up. It's not below the cell, it's up the cell. But in the end, you have a Python programming languages which now knows basically languages as a variable. And it seems so simple and very easy now, but think about when you do a lot of coding, and as a data scientist, you often reuse code, you adjust it, you copy paste it from some elements. Then suddenly you really learn that, oh my God, I did a big error in the kind of structure, how the code is when you introduce which languages and so on. While this is of course brilliant when you have nothing defined that we had before, so you can also do this. Okay, then you get a feedback. Of course, think about that when it is defined, you can say, I remove here again the Italians, and Rocco, one of my PhD students, also here on the call. Sorry for this, Italian. When I do this, now I have the languages like this, and up there I suddenly miss Italian. So even if I had before, if you remember, Italian within defined, and I would think about this maybe, but I executed the cell that redefines it, or you would have it in a cell up there, right? Also sometimes happening, now it's defined here, and now you would think like here, I want to have all 4 languages, and if you come here, you don't list it, and suddenly you don't have Italian. Although from the source code, it looks like, aha, languages, and then there should be languages here. Of course, that's why I introduce a little bit this thing of restart and clear output. So when you have a mixed up code like that, I have now with 8, 10, 9, maybe something down here, 11, think about that every now and then in the walkthrough through the assignments we're gonna do, it should remain a good numbering, right? So of course, when you have, let's say, one error and restart the cell, you increment just by one number, by one digit. It's not a big problem, right? So in the assignments, I don't care if it's 8, 10 or 8, 9. But think about it that if you have a complete mixed up code, maybe like now, that sometimes it may be useful for you to restart and clear output. There's no harm in this. Your source code will still remain, but then you have a much more clearer structure. You will do what you essentially planned to do step by step in all the different cells. And suddenly we have Italy back again in the game. So this is maybe a little bit awkward kind of thing, but I have seen in some of the demonstrations and some of the tutorials we do with real new users, lots of messing up of this. That's why I iterate a little bit here on this. Just way forward on this. And let us come back a little bit to what else we can learn. We have seen already now, and I don't repeat this now, we have seen hello world basically as a basic variables. We have seen that loops exists. Of course, you would have some for statement there that you can have. That needs not to be a string. It can be numbers that you know maybe from Java iteration. So whatever you do. So this is something what we explored. We had if statements, which are quite interesting. And note the indent in Python, right? It will give you a little bit now a pointer of where is what executed. If you put the if not in the indent here, it will be executed after the for loop. So careful with the indent. So Python is very much keen on this indent of the, essentially indent means a space that you would have here. The benefit is if you use Python now in the demo here or in the real use, basically if you have something like this, you write for, you will see that an indent is usually happening automatically in Jupyter and so forth. So you're relatively safe on this. So if statements is what you would assume from a normal language, of course. Think about that scientific computing and engineering computing and so forth are often have vectors, matrices, arrays. So in this sense, it's not all about strings and so on, maybe more about numbers. And you want to have some interesting tools to really work on numbers. And this is really Numpy. It is already a very good tool. Here are some examples. I already demonstrated that Numpy here, the first part of this import statement I will show you is important. So when we go maybe out of this and have vectors, as an example here, I prepared this a little bit, you will see that when I do Numpy here, in terms of this, this is not really known. So the first part is essentially something you cannot mess up with, but you're free to choose as NP variable, right? So which means you can also call it NU or number pi if you want. And then basically you would have NRP here doing something. But there are some more or less conventions in the community that NumPy is always this. So with that, you basically are safe. Note also that in basically in the Python environment, also the others have been already known, right? So you have seen that I could use either NRP or, it's another good example how this can be sometimes misleading if you just look on the source code. Think about that this carries a lot of weight that you executed something, right? Again, if you do kernel clear output, you will see that suddenly your source code is not running anymore because nobody knows really what an NRP is. Of course, this should be a NumPy. So these are little differences, little problems, but we have seen that actually debugging them every now and then is quite a big issue. Similar goes with this vector, and if you want more an array notation, you see clearly here on this notation. So what you have here, it looks the same actually, right? But this is a different aspect than we have here. Note that we here have just 5 values that we put together. So this is just essentially an array. And here is more a vector type where we say it's a dimension of 1 times 5, right? So, and you see this with these 2 brackets here. I also noted you this here somewhere on the slides. Wait a second, so that you can follow up on this, because if you have here now some machine learning or deep learning code, and you just walk around with this and you use NumPy very often usually, especially if you try some code out or you want to have some random numbers as I did here, then sometimes these things matter. Of course, in the end, if you want, it's very similar, right? An array of dimension 1 times 5 and a vector of dimension 1 times 5. But take away that these little things actually matter. If you then use other libraries and you put some wrong data structure inside, this could be really harmful for your code. So these are the kind of traps sometimes in machine learning codes. Usually in the walkthroughs that you have in the assignments, this will be not the big issue, but let's say if you have to change here and there a couple of things in the source code and you overlook this fact, this could be, of course, then harmful, and you wonder why it's not executed. It looks exactly the same, but it isn't. Then matrices, of course, are big in NumPy. Also, this is, I guess, no surprise. We use them a lot. And if you want lots of machine learning these days is matrix vector multiplication, matrix multiplication. I think this was something I created for matrices. So you see, you can also, maybe as a good example, rename aspects, structure really your code. My suggestion for your assignments also when you use something like this, also make good naming or different versions, right? You can here nicely say matrices duplicate. Let's say when you want to advance from an initial version to another one, and then you rename it and say this is here matrices before strange edits from Morris or something like this before you submit, whatever it is, but keep a little bit the source code clean that you have. It enables you later when you submit the assignments easier with, you know, things like screenshots that I will require to really get an overview of what's happening. Right, so looking in this, we could then go to some examples from matrices, but I think from the time and looking at the time, we maybe want to explore something more interesting, and I explain it just with this. Also here you have a different, let's say, type again, how you can create matrices out of a Numpy array, for instance, that you create by hand. Here it's quite nice and neat to do so if you are, want to test your code out and to understand really which values are inside. And here you basically have another way of a random way of creating it. Note again that the way how you create this, like a vector we have seen was 1.5 or 1 times 5. And here the matrix that we create, right? There's a difference, vector versus matrix. Here's a matrix with 2 times 5. And then basically if you can print this, you see you have like 2 different basically rows here and 5 columns. These are all little differences, but of course it means something if you go and practice and want to work with Python. Okay, but I could carry on with simple Python and NumPy and so on, basically for a whole course. And I don't want to do this because there should be other Python courses around. And also online, there are lots of material how you can really debug Python. Just look for an error and usually you get an answer with Google immediately. So let us come a little bit more to really use now Jupyter again remotely, maybe as an example. Then we will see a couple of things which are interesting. And the reason why we want to do this is what I told you at the beginning. We want to have a real nice application. And one example application in deep learning is this character recognition, which means essentially you want to have a system that tells you automatically from an image of a handwritten character that you see on the bottom right, what class it is. And the class usually reflects really the digit. So you see the top left is a 0, the bottom right is a 5, and there's a 3 on the top right. So you want to have essentially this automatically analyzed, which is nothing else than basically 250 pixels in different, let's say, white and gray colors, if you look closer to it. And this is exactly what we want to do now. And by far in machine learning, you will find that basically you would have lots of different work to do, which we call data pre-processing or data preparation. Some refer in the engineering domain also to feature engineering, feature extraction, things where you work on the data, you will understand the image better. It could be time series as well, but here we stick to the images. But basically you always look at the data set and see how we work with it. And you will see there are lots of challenges with this, even with this simple data set here. One example is that you can stick this images not in an artificial neural network. It needs to be vectorized. It's something what you can't understand right now perhaps, but we will see how that materializes when we have subsequent lectures. However, what I want to first also in machine learning and working with data, big data, I want to understand the data. So I have to write me something that, can investigate the data, how the data looks like, what I can do with this. And basically, usually what's done is it's often Python codes which are used for this step as well, where you will understand a bit better how exactly now these images there are there. For machine learning, it makes also a difference if there's training and test. And if you noted, we will have a really, let's say, short introduction to machine learning later as a lecture. So I don't will spend too much time about it, but usually have several data sets which in a way have the same data, not exactly the same data, but the same type of data in order to learn from the training samples. And then actually you check out if you really have a good system by using your test samples. Now, this is something what happens now when you are already in a company or you're a scientist after your studies and someone knocks on the door and says, well, here is a 10 class classification problems with the digits. So can you help me? And the first thing you ask is, okay, what data do you have, right? And this reflects then basically that we want to do this. Now, when we now have this as a demonstration, there will be some surprises in the things that I want to do. The first one is the interesting thing with this MNIST data set, it's often used for tutorials. So essentially it's already inside these packages that we want to use. So we want to use Keras here as an example to say, there's a very nice feature called MNIST load data, and I just can download this, right? Indirectly, it comes then, you know, that it is a Numpy or basically compressed Numpy array that you see here, NPZ. And from some other site at Google and so on. But in the end, it's already there, so I don't have to upload it and so on. This is a very special situation, of course, but makes it easier for us here in the tutorial. However, you will notice that Keras is unfortunately not often directly deployed. The reason are several ones. One of it is that the installation of it is not always so straightforward. Another one is that TensorFlow was already predicted to have Keras included. So there are lots of different reasons for it. The point is we can solve it, usually quite easily with using pip install. So pip is also would be a complete lecture to talk about. So with pip is a kind of installation that you require if you really go low level on a system and want to install different Python packages. So maybe also in the remaining part of this lecture that I don't talk today, think about looking shortly on pip. You will see that everything what you require for Python, you can add with this pip install usually. And here's one example, pip install user Keras that we gonna do when we do now in this JC remote computing example, some interesting part. Let's go there. I think firstly, I maybe close a little bit from the local ones because I have here so much out. So I would say the matrices one, cancel. Usually to make it proper, you should do something like close and hold, and then you can leave the page because these will be running as entities somehow in the Python space. So it's better to close and hold the kernels before you just abrupt essentially close here the tab. Also, this is gonna close and hold just to get a little bit an overview again. So now you see again here the difference. This is localhost. So this was basically what I showed you before and the simple examples. And now if you remember, we were logging into this interesting remote Python aspect here. So remotely Jupyter. And we have in Python notebook, which is nice. And we want to do something on it. Now, luckily, I have already prepared something. So let's load this up, which basically is in the desktop. The pre-processing here. And if you open it, we see already there's some code. Okay. So this was a little bit prepared before. As I told you, it has already some output. So what we want to do here is to clear all outputs, essentially, and to see what will be happening. So all the steps I do now here and to explain are, of course, also step-by-step inside the slide sets, right? So that you have a little bit an orientation in basically also in the light of the fact that it is a demo and you can see the recording, which is very nice, but you have also always the slides that explain here and there also a little bit more. Again, from the Python perspective, you would have here the Numpy, which is nice, we use later. You would have also Keras now. And Keras is now this deep learning package, which has already a couple of data sets, often used for benchmarks, often used for tutorials, trainings, teaching. And we want to execute this. And you would see that there is no module named Keras, right? Which means essentially this Keras package is not there. So what we want to do then there is basically we say, okay, this kind of failed. I would say then we have to basically stop this, or a nice way of doing it was restart kernel, clear all outputs, maybe to leave it clear. We have to work somehow on basically getting now Keras installed. And you could have a new launcher and opening the terminal. And this is very similar on many cloud environments. You go to something we call the SSH terminal, the different names for it, where you have a command line interface. So admittedly, this looks a little bit, old school, that's for sure, but you don't have to do there very much. In previous times, let's say in 10 years ago, 5 years ago, we were using SSH queues, which are still used today to come to this kind of environment. And now today's environments in clouds, usually Jupyter is very established, so you don't have to go that way. And of course, if you go to commercial clouds, chances are there that you can just with a click get Keras. So you don't have to do it necessarily on your own. But as I wrote here on the slides, this pip tool is quite nice. So we can say pip install, and then essentially we have a small special aspect, which means as a user, not as an administrator, you want to install Keras. And this will usually take some while. It depends a little bit. Sometimes there are firewall issues. Of course, when you go to some clouds, you define your own firewalls for networks. Sometimes you will see in Amazon when we go to infrastructure as a service level. For instance, they are already automatically firewalls, and then you don't really can do anything and download. But this is, of course, something then which has to be open for pip and stuff like this. And you can configure these days in clouds very easily. So interesting thing is, you see with pip install user Keras, we did this. We installed our own Keras for our user. And there are more advanced features. You can basically say that you want to have this in an environment, you reload the environment, and all of this is a little bit more elaborate and not part here of the lecture today. So thinking about this, that we now basically have this Keras installed, we would assume that when we execute now this pre-processing, it basically should work. But basically what we also have to do is probably restart the kernel, because the kernel will take into account now what's there newly installed. And if you remember, we didn't really install it new, and should work right now. And you see now there is a star or an asterisk, as you sometimes call, and basically say it's processing something, and it was successful. Which means now we have Keras, we can work with it. It is a huge library for deep learning, often used in teaching. We will use it significantly in lecture 6 and 7, and also in assignments. So, but there's a very nice way of understanding layer-wise how a deep learning algorithm, how a deep learning network is really working. Another aspect of this is now we import this MNIST, and this is just this handwritten character recognition I was introducing before. As I said, these data sets have this already, which is very nice for us. But for machine learning, we need a little bit more. We need basically the data we call X, and there will be a complete lecture. We will talk more about this and go into this in detail. We will have the data, which is usually called X. It's here basically all the pixels, 28 by 28, but also something we call Y, which is then the label. The label tells us when we train, it is really a 0, it is really a 5. So someone took already the work of indicating for these data set that this is a 0, that is a 5, that is a 3, right? And this makes it labeled data. I give you a small example here to make this more obvious for you. Here on the slide. So you see, that's what we have here is training and testing data sets. This would be the training data set where we learn here from these numbers. And in order to learn what it is, we have to know what it is when we want to learn it first, right? So here we have label 5. Here we have label 0. So this is what we mean a label. You can also see now a bit more how that thing looks like. So we have here different indications of gray values, right? Intensities from 255 up to 0. So this is white space. This is here really black somewhere, saying it's a 5, it's a 0, depending on which of these pixels essentially you actually do. And it's a matrix 28 by 28. Now in machine learning, and we will come back to this in the real machine learning lecture just shortly, This is an important factor. If you're swimming in data, that's even better. So saying that big data is always better is wrong. There could be lots of noise in the data, where we will talk about in machine learning, but also in general, you would say the more data you have, the better. And that is actually also why big data algorithms in deep learning work so well. We have now lots of images. We will explore some of the open image archives, where ImageNet, for instance, has millions of pictures already, where you can learn what is a cat, what is a cow. It's nothing else. It's also a label. It does not need to be numbers, right? But you learn from this. This is not all obvious to you. We see how that materializes through the course of the lectures when we have all the subsequent lectures. Here's now rather the idea: someone gives me data and I have to separate it in a training set and test set. But in order to understand it, I need to know more. I want to look at the data. I want to not know just, okay, you give me some pixel data. What is it? What values are there? And what can I do with it? And this is essentially this script that we have here. So let's go back to the interactive demo here, where we will have now the separation. And this is nicely done, that it's automatically basically done in downloading the data. As I said here, you have to be a little bit careful depending on which environments you are. There could be firewall problems, so you have to execute it on a separate environment. And I will talk about this walk around in one of the subsequent lectures, and also part of our assignment. But here you see it was downloaded, so the data is available, and it was automatically now put in the separate data sets. So we have two kind of data, or essentially 4 variables now that you see. We have the X train, saying all the images of handwritten characters. We have Y train, which is a subsequent label for each of these images, saying it's a 0, it's a 5. But we have also a cut in the X test and Y test of the data. So essentially saying we created here automatically the training set and the test set. And this is something we come back to throughout the lecture when we face machine learning algorithms. It has also an interesting impact in big data. So we will talk about this also in the subsequent lectures, why that is an issue, and of course, why cloud computing is so popular. Because if you have big data for machine learning and you always want to download this on your local laptop, then you have really trouble. Always, downloading the last retail data of gigabytes, maybe getting towards terabytes in the future, if you include image data, right, of perfumes and so on. So things like that is something to think about. Now, when you think now about Python again, about Jupyter, it was very quick. We had a couple of source code lines. We have the data downloaded already. We have a data structure for it. And now we want to have a small function, which is nothing else that I wrote for each of the characters to say something about it. And we will go through the test set now. It really doesn't matter if you have a test set or the training set we go through, but we want to know how it looks like. And you'd have some investigation in the data. That's part of the data understanding phase, of the data pre-processing phase. And to no surprise, it's similar, like of course I had in the basically in the associated slide set here. You see that's exactly what we get when we play around with these items. And you see how quickly we can change things. We could here then say, okay, that was a test set, but what about the train set? That's awkward. Should we look at this? So yeah, well, the train set looks pretty much the same, right? And here you see label 5 for this digit. You see a label 0 for this digit. So it seems like very nicely someone did already the work where we can learn from very brilliantly for machine learning, and then put it to some unseen data where we don't know the label. So machine learning, the goal would be, of course, now that if you have some new digit, you write something yourself, and we put it as an image, 28 by 28 pixel, into the system that we here created or will create in lecture 6 and 7, then it automatically says it's a 5, it's a 0, it's a 4. Admittedly, this will be never 100%. There will be some 5s which are completely remarkable bad. Particular computer scientists have a proven track of being always not the best in handwriting, but it's important. And I think here that's really it. In the moment, normally we would continue then with lecture 6 and 7 now and would say reshape the data. But I want to give you, in the sake of the time, also a little bit a short glimpse on another aspect we will focus on in some of the subsequent slides coming up in other advanced lectures when we think about big data rule mining and association rule mining. This is something where you want to really have shop data usually, but it's used in bioinformatics as well. It's used in other domains. But here you really find out what is, for instance, a product which is mostly bought with another one. And there are different algorithms for this. Here we just picked an a priori because it has a very nice tool set in Python for it from the ML-Extend library. We see it has some scalability problems we will later on focus on when we think about big data. What's the problem with this? We see how FP Gross partly solves it, but still really big data requires more than just another algorithm. It requires another execution environment. But lecture 11 will be all about it. So here, not the details, just relatively short in explanation what an application could be for this area. And again, how Python simply solve this, right, in a very easy way. It's part of the work we do here in the On4Off project. As I said, my PhD student also, Shadi, is here on the call and it's also accessible in the discussions if you want to learn more. And we will hear in lecture 11 more about it. Essentially, it's about looking at all the transaction data, right, purchase data. What are people having put in their market baskets? And looking at these transactions, if we can find some rules, if we can find some patterns there. And here's an example, which is a very, very famous data set example. Really, I guess many of you have heard the diapers and beer example, that this is always bought together, or in let's say, in the majority of cases. And we want to basically find a rule like that in this data. Now here it's very obvious that diapers and beer are always bought together, but there are many, many patterns which are firstly not one level. So that means it basically means not one product means another product. Essentially, it says another project, so two products actually mean one product, right? So this is something to think about. Here, for instance, it would be that bread and milk seems to be often go with diapers as well, while bread and milk will not necessarily mean that you have cola, because cola is usually here in a separate area. Now, the point or the explanation of this in the media and everywhere is usually that basically you buy beer only in the UK when you have a kit, because otherwise you will be going out to the pub and take the beer, but definitively not at home, which means if you have a kit and you're stuck home at the evening, you need to have beer at home. So this is kind of a shopping pattern which is known, but take away the message that, of course, you want to understand now, if a customer comes to you, you have a consulting company basically, and it says, well, I have this 1 million transactions here out of my cashier. What can you find in terms of patterns? And then you will start, you will say, okay, that's data, interesting. Here we have data mining, we have not machine learning, so we don't necessarily need a complete training and test set. We can maybe go with a ruling in itself. We need a nice package for Python, which is here nicely shown. It's the ML-Extend package, which is a very nice data mining package. It has also several other algorithms which are quite useful. And this is something what is again the same story. You would say, okay, that's very easy then to create. We have several application areas where we could then give what we get out of these patterns to the boss of the store. We can say, change the product portfolio. There are some products never really bought together. We can have a store setup change. So to take the longest path through the shop and ideally through the sweet corner. So to pick in some chips and some chocolate. So there are lots of areas how you can actually have your store reorganized on this, what we actually do also in practice with PAAS. And there are lots of configuration options, of course, for those algorithms. So where do you draw the line? What is a good recommendation or a good rule? Which is support and confidence. Things like this we will all explore in lecture 11, right? And support is really an important part here, meaning how much it is really appearing. But of course, there's several other aspects to it where you basically have other configuration options. So let's see how that shortly works. I go for the basically for the sake of the simpleness, again to basically again back to the to my local system here. You see association rule mining. We have here an example of PEPA perfumeries, just because our project we work with is really PEPA perfumeries. And of course, take away the message that I basically have here a little bit a simplified data set. It's not the real transactions we got from PEPA, just to show you a little bit more what this is about. You see here we use also pandas, right? For the data frames I was exploring, we use the MLXtent library and import there the a priori algorithm and association rules. And a little bit we want to later maybe plot something where matplotlib is usually a good example. So when we load this, there are usually no surprises. Of course, MLXtent needs to be installed with the same pip command I just did, and I did this before on my local machine to make it a bit more faster here. We can read nicely from the pandas data frame, as I was alluding to. This is a comma separated file showing all the transactions, what goes together and so on. So when we go to this directory, maybe it's better explained. We say PEPA fake. You see essentially just a shopping basket and say, these are the products that have been bought in the different shoppings. And it doesn't matter who's shopping this, it's other algorithms. Here it's just the plain shopping data. And you see here some of the names, which of course are also basically simplified. And can go through it a little bit looking what brands are there. And now the question is, can we say something about this? And what we have to do there is again a data pre-processing, because the algorithm a priori wants something we call one-hot encoding, which would be one of the key limitations of this algorithm. Instead of a tree structure that FP growth, for instance, employs, this is much more of a one-hot encoded big matrix. And if you have, of course, now a product portfolio, you can imagine, of really 30,000 products, you would end up with a very tall matrix. And this is one of the problems we will allude to in lecture 11 when we talk about it more in detail. But you see essentially how quickly with Python and with this Jupyter Notebook here, even locally, I can go through this. This is just a little bit of Python code going to a transformation of this comma separated to some big matrix which says a 1 for the occurrence or a 0 for not being in the basket. So each of the baskets will be analyzed and 1 or 0s for the products. And here is really just using the a priori algorithm, which has the support options, if you remember. And we can say the most apparently around the clinic. So this has lots of support, is really appearing incredibly often, which is a good indicator for us that this would be perhaps something trusted. And now we do the rules on top. So you want to understand maybe to show really what is bought in which scenario. If, for instance, someone has some specific brand here, what we can recommend. And again, the interpretation of this confidence, lift, and leverage, and so on, we will do in lecture 11. So be with me, but here you see already that some of the things have different values, especially the support. And you would say mostly if people have, for instance, a bioterm, we would recommend Clinique. Now this is a very simple data set. You see Clinique is basically done in almost all the cases here. But here we say bioterm and Clinique has also a very high confidence in it. So before you get to the customer in your shop and say, well, you can buy this and this and this, and you go to everyone and say, please use Clinique, pick those which actually have bioterm in the basket and you recommend Clinique. And then what you have is essentially basically a very good confidence that actually they will buy Clinique. And there will be other examples where the confidence is not that high, where support is not high, where you maybe let this going. And of course, from practical experience, which is one part of this, you should not give 200 recommendations that people want to, you know, also get sometimes out of your shop. So all what I just presented is essentially on the slides here. We see a little bit more about the perfume stores here, that it's simplified data. If you go to the real data sets, it's incredibly harder. You have perfume sprays in different milliliters, lots of different things we will explore in lecture 11. and of course then understanding the support option. Again, when you think about relevant rules, maybe from the practice to stop this, also to show you very quickly now with Python, we have to make maybe a store happy in retail. And the sad fact in Germany is that very little people use data mining and machine learning. That's why retail has a real big problem. And also in COVID-19 times, especially. So you have seen there's a couple of Python lines now when you would have real data coming in, chances are from a moderate shop size with moderate number of transactions, you can already make a difference to say something about the data that the people don't know in the shop. Right, but more details on this, I really want to give someone to a different time. Here's just a bibliography, and I think the acknowledgements, as I said here, much of this work is really done here by PhD student Shadi, and the subsequent work in the back end is also done by Rocco, especially if we go to the deep learning setup and thinking about Horowitz structures. So with this, I would like to stop the recording today and entering the Q&A session.